Okay, I know I said you were done, but you weren't done. I'm sorry, and you're going to have to listen to me just a little bit more. There's one thing that I haven't really shown you here, and that is how do we solve for a missing angle? Well, what we know is two sides, right? And this problem is asking me what is the angle between the diagonal and the bottom edge of the flag. So between this diagonal here and the bottom edge, so what's the measure of this angle is what it's asking me. Well, I know this opposite side from it, and I know the adjacent, so that would be tangent function. So I want you to watch. I'm going to write this out as fast as I can. Try to, trust me, I'm trying to go home right now, so I'm going to do this as fast as I can. I spent enough time on this tonight. All right, here we go. So we have we know that the tangent of that angle, whatever angle that is equal to, what was those measurements again? 7 over 20, right? Because it's opposite over adjacent, so 7 over 20. So now we need to know, well, what is theta? So remember in algebra, when there's an operation that's performed, we do the inverse of the operation to cancel it out, right? So is there an inverse of the tangent function? Well, it turns out there definitely is, right? So what do? We say take the inverse tangent, right? And we use this sign for inverse, right? -1 to the -1 power means to create the inverse. So if I take the inverse of this side, I'm going to have to take I have to write this poorly here, but the inverse of the other side. So these two are going to cancel because it's saying, first this one says perform the tangent function on angle theta, and this is perform the inverse of the tangent function on the tangent function of theta. So they cancel out, and we're just left with theta. It's equal to, but since we had to do it to this side, we have to do it to the other side. So theta is equal to the inverse tangent of 7 over 20. So thankfully, if we need to find an angle measure, and we know our ratios, and we know the two sides, we can use the inverse function. And let me tell you, you remember my right triangle machine that I was doing on there, and we made that spreadsheet, and on the spreadsheet, all those, all the angles were listed, and for every angle we had our sine, our cosines, all listed. They're all calculated. It used to be in the old days that there was before they had calculators that stored in its memory, you had to go to a table and look it up. You had to look up the value of the tangent of 7 over 20. You actually had to, or the tangent of theta degrees. You would go to the x, you'd look up how many degrees it was and go across until you found the tangent value. And that's how you'd know that. That was the old days how they do it. Now, of course, we have them stored in the calculator. And of course, if you ever were on a test, you didn't have a calculator, but you had GeoGebra, you could make a full list like I did if you built out a right triangle machine. But whatever. Anyway, what we're going to do here is we're going to use the calculator because all the tangent is just looking it up the other way. So if I find, okay, I go down my column, here's my tangent column, I find this is the tangent that I need to find. What was the angle measure? We're just going backwards over here and finding the angle measure. So how does that look on the calculator? Well, it looks something like this. You remember that we have the trig functions down here, and I'm sure you've seen this, maybe noticed it by now. Okay, when you hit your trig functions, there is the inverse tangent. So we're just going to put in the angle measures, which were 7 over 20. So control divide, right? That gives me the fraction template, and I go 7 over 20, and then I'll just hit control enter, and I get 19.29. So this will be my answer that I'll put in here. She needs to make that a 19.29 degree angle in order for it to have that ratio of a tangent of 7 over 20. Okay? So that's how those problems are done. Thank you.